All right, this is going to be a Math 1 Unit 3 review. Hopefully it's a little bit of a review session for you guys as you get ready to take your Unit 3 test in the next few days. Before we start, just want to kind of go over a couple things before we begin going through this process. This unit had a lot to do with points and slopes and intercepts and things like that. And there essentially were three terms that you had to learn. One was slope-intercept, and you had to learn what the form of that looked like, and that was the y equals mx plus b. We'll be using this a lot today as we go through this review sheet. Y is, the y value, x value, m stands for your slope. If you recall that there, that's going to be the rise over the run, and the b is your y-intercept value. And again, remember, slope is always going to be rise over run. How much you go up or down over how much you go side to side. The other form that these things come in is also known as the point-slope form. And you have to write things in the point-slope form, which is written this way: y minus y1 equals the slope times x minus x1. We use this a lot when they actually give you some points to work with, y1, x1. And that'll come up throughout this process as well. And then finally, we were introduced to the standard form, which looks like this: some value times x plus a value times y equals c. For this unit, you have to be able to go back and forth from slope-intercept to standard, from point-slope to standard, back and forth, and being able to use these interchangeably. So this will come up throughout this review session. So keep that in mind as we go through this and what we're going to do. Okay, so when we look at the first question in the review says to find the slope of the line that passes through the points -5, 6 and 3, 7. To find the slope of a line, what I'm looking for is essentially the change in up and down divided by the change in side to side, which is your slope again. That's your m value. To figure that out, what I'm going to do is use the formula that you were introduced to in one of your early lessons, which is y1 minus y2 divided by x1 minus x2. If you recall, it didn't really matter which one of these you wanted to call y1, y2, x1, x2, as long as you were consistent. So if you wanted to make this your x1 value and this your y1 value and this your x2 value and this your y2 value, you could do that. That's not a problem at all. So it's totally up to you how you want to do that. So let's pretend we did this way. So we're going to do y1, which is 6, minus my y2 value, 7, over my x1, -5, minus 3. When I solve this here, I end up with 6 minus 7 is a -1 over -5 minus 3 more makes a -8. The two negatives on top of each other there are going to go away, so I'm left with simply 1/8 as my slope for this line that would pass through those points there. I would get the same result even if I went the other way. Let's pretend that I went with y2 minus y1 over x2 minus x1 and went the other way. If I did that, I'd have 7 minus 6 over 3 minus 5. So 3 minus a minus 5. When I have a minus, that becomes plus. And so I'm left with then 7 minus 6 is 1 over 3 plus 5 is 8. So I end up with the same slope both times, so it doesn't matter which way you go, y1 minus y2 or y2 minus y1, as long as you match up your tops and bottoms. So choose the ones or the ones and the twos. It's totally up to you. So that's my slope. All right, number 2. Write the equation of the line in point-slope form. Recall that point-slope form up here is going to be y minus y1 equals slope times x minus x1. They tell me that the slope, m, is already -5, and they give me some points right here. -7 is an x value, and -11 is the y value. If the point-slope formula is y minus y1 equals m times x minus x1. Essentially, all I'm going to do is just plug those numbers in for the variables. So y stays y, and I'm going to subtract. I'm still going to subtract here my y value, which is a minus 11 or negative 11. So I put that there, equals my slope, negative 5 times x. That's just a plain old x there. And I'm going to subtract my x1 value, which is a minus 7, minus 7. I probably don't want to leave it like that because I have minus and minus and minus and minus. So I'm going to change those around. When I subtract a negative, that is the same as adding. And then I leave my minus 5 just as it is, times x. And I have minus a negative 7, which is the same as plus 7. And I'll stop right there. So now I'm in the point slope form, which matches what I had up above. Y minus y1 equals m times x minus x1. And I'm in point slope form. Okay. Number 3. It says to go ahead and change this into the slope-intercept form. Again, the slope-intercept form was y equals slope times x plus b. So I want to be able to change this around a little bit. That's not a minus. I'm sorry, in this case it looks like one. I'm just drawing a little arrow. Y equals mx plus b is what I'm wanting to do. So to do that, what I'll do is basically this. I'm going to use the distributive property. I'll write that down again. Y plus 11 equals negative 5 times x plus 7. And then using the distributive property, what I'm going to do is I'm going to say, okay, well, in this case, let's go ahead and multiply this out. I have negative 5 times x for a negative 5x plus this value here, negative 5 times 7 is a minus 35, and this is still equal to y plus 11. Because I use the distributive property right here, now I have y values, x values, no parentheses. I'm getting a little closer to what this looks like, but I want to make sure I end up with just the y by itself. So to do that, I will subtract 11 from both sides, like here. That will cancel out there. So on the left side, I'm left with y equals negative 5x, and then I have negative 35 minus an 11 for minus 46. So now I'm in that y equals mx plus b form, for slope-intercept form. So my answer is right there. Number 4, looking at the next one. Find the x and y intercepts for negative 5x plus 10y equals negative 30. Okay, so if you recall, the x and y intercepts means I'm looking for where does this equation cross the x and y axes. So here's my y, here's my x, and I want to know where does it cross this line at, okay, for the x-intercept. So whenever the x-intercept crosses this little line right there, wherever it might be, I can tell that the value of y will be 0. So when y equals 0, that's my x-intercept. Okay? So when y equals 0, that is my x-intercept. Good with that there so far? But what I also know is that when, this is my y-axis, when x equals 0, that's how I find my y-intercept. So I'm looking at two different things. So one way to solve this would be to write the equation out 2 times. Let's write it this way. I have negative 5x plus 10y equals negative 30. And over here I'll write it again for negative 5x plus 10y equals negative 30. So to find the y-intercept, I want to set the x value equal to 0. So here we go. Negative 5 times 0 plus 10y equals negative 30. 5 times 0 is 0. So I'm left with 10y equals negative 30. To get the y by itself, I'll divide both sides by 10. And y equals, reduce this down. Negative 30 over a 10 is going to reduce down to negative 3. So my y-intercept is negative 3. This is my y-intercept. I'll do the same thing for my x-intercept. The x-intercept will happen when I set y equal to 0. So I go negative 5x plus 10 times 0 equals negative 30. This goes away. So I'm left with negative 5x equals negative 30. I'll divide both sides by a negative 5. And I'm left with x equals 30 divided by 5 is 6. They're both negative, so I end up with a positive 6. So my x-intercept is 6. Those are my two values there. So again, I just plugged in the value of 0 for x over here and for y over there to find the x and y intercepts. For number 5, slide this down a little bit here for you. Number 5, we're going to find the y-intercept for y equals the absolute value of x minus 0. Again, for the y-intercept, that means I'm going to make the value of x equal 0. So let's just do that. Y equals the absolute value of 0 minus 3. 0 minus 3 happens to be minus 3, but I'm still in the absolute value world, so I leave it there. Well, what is the absolute value of negative 3? It's 3. So my y-intercept is at y equals 3. If you want to write that as a point, you could. It might show up that way as well. So when x is equal to 0, y is equal to 3. And that is my y-intercept. For number 6, it's asking you if these lines are going to be parallel, perpendicular, or neither. You'll have a question like this on your unit exam as well and have to be able to match which is which. So I have two different things here. I have this one written in standard form and I have this one written in point slope form, so it may be a little bit hard to compare. What I would recommend is making sure that they are in the same form in order to be able to tell what is that slope looking like. The way you're going to be able to tell is if a line is parallel, the slopes are equal. Okay, so if one slope is 2, the other one happens to be 2. When I'm looking at something that's perpendicular, what's going to happen here is if the slope of 1 happens to be 2, for a perpendicular line to happen, that's a sign perpendicular, I'm going to get the opposite. So if it's positive, I make it negative, and I have the inverse of it. Instead of 2, I have 1 over 2. So I basically am taking the number and I'm flipping it, and I can go both ways. Let's say, for example, that the slope given to you was negative 3/4. If I wanted to find a perpendicular line to that, I'd flip them, and I go 4 over 3, and I'd make it positive. Neither would mean they don't match at all. So if I had a slope of y equals 5x plus 2, and the other one was y equals 2x plus 5, I see that my slopes have nothing in common. That's a 5, that's a 2. It's not equal, it's not the opposite inverse of it, so we're just going to leave it and say that's a neither. So when I look over at this problem here, they give me 4x minus 5y equals this, and this one here, I can already see that I have a slope for this value of 4/5. So I'm going to go ahead and change my standard form into slope-intercept form or point-slope form, whichever one you're more comfortable with, to find out what the slope might be. So I have 4x minus 5y equals 6. I'm going to go ahead and move my 4x over, so I'll subtract 4x from both sides. These are different, so they don't subtract from each other. I have minus 5y equals negative 4x plus 6 by moving. I'm going to move it for now because it just looks funny. I'm going to move it around. So I moved the 4x to the other side, slid it over there. I'm getting a little closer. But I don't want the 5 with the y, so now I'm going to divide each part of this by a negative 5, by a negative 5, by a negative 5. So on the left side I'm left with the y equals 4 over 5, minus minus becomes a positive, so I have 4/5 x, and on this side I have plus minus, I end up with a minus 6/5. Because I'm just wanting to know, are the lines parallel, perpendicular, or are they neither, all I really worry about right now is that I look at this and say, well, guess what? This slope is 4/5 for that one, and this slope is 4/5. So because they are the same, then I know that they are going to be parallel lines. If my answer had happened to be negative 5 over 4, we would then say, oh, they're perpendicular because I flipped it and it's the opposite. But that's not what it says. So don't say that that's right. All right, let's go to the next page. Okay, sliding down here. Again, I always recommend that as you do this, you look at the problem, and before I work it out for you, you push pause on your video, try to solve it, and then see if you come to the same conclusion that I come to. It's possible I may get them wrong from time to time, so you might want to check my work too. All right, so number 7, we have f of x, which is a fancy way of saying y equals 3/5 x minus 3, and it says to choose all that apply, which means I have some points, and because these are all my x values and these are all my y values, the way I do that is I'm going to just say, well, let's plug in the x value into the equation to see if I get the y value. One of the things I noticed right away is that I have a 10 and a 10. So if I plug a 10 into here and get an answer, I'm not going to get both of those answers because it just won't work. Just like here, I have a 0 and a 0. So when I plug a 0 in, I should get one answer, not two different answers. So I'm going to do two equations. Here we go. I'm going to do y equals, I'm just changing f of x to y. That's all I did there. And I say y equals 3/5 of x minus 3. Let's go ahead and plug our 10 into it first of all. So y equals 3/5 times 10 minus 3. Alrighty, so I could either reduce if I want to before I multiply, up to you, 10 over 1. I could say this reduces down to 2 and 1. If I wanted to multiply it out, I could have 30 over 5. Either way, I end up with 6 minus 3 on this side. So y equals 6 minus 3. 6 minus 3, last time I checked, happened to be 3. So when x is equal to 10, when x equals 10, y is 3. When 10, oops, that's a 1, so that's not going to be okay. 10, y is 3, yep, this was going to be okay. I'm not done yet because I still have the zeros. So let's do another equation. Y equals 3/5 x minus 3, and now let's plug 0 in for this value of x. Y equals 3/5 times 0 minus 3. A little easier equation here because y is equal to, anything times 0 is 0. So all I'm left with is a minus 3. Y equals minus 3. So when x equals 0, y equals minus 3. I look at my choices, 0, 3, nope. 0 minus 3, yes. So I did two different equations, plugged in the value of x to see if I could come up with the correct value of y. Alrighty, number 8. Number 8 is a great one. We're looking at a linear function, determining whether it is a linear function. It says that it is, showing Bob's distance, the distance Bob has traveled in hours and miles here. So we have him from 1 hour, he goes 45 miles, 3 hours, 135, 5 miles, 225. It wants me to find the slope and the average rate of change between 1 hour and 5 hours. So the slope is going to be, again, the difference between the two terms. So the difference there, or the change from one to the next. So if I want to look at, for example, let's go simply here. The change is going to be, we said before, that term of y1 minus y2 over x1 minus x2. This is the change, or delta, in y, and the change in x is what we're looking at here. I'm going to look at the miles per hour is the way I'm going to set mine up. So I'm going to call this my y and this my x. And it's like a t-chart or a t-table, except it's sideways here. So let's go ahead and select a value for y1 and y2 and x1 and x2 for now. We'll use these ones. All right. So if we say y1 is 135, that doesn't matter. y1 is 45 minus y2 is 135, and I divide that by x1, which is 1 minus 3. I end up with 135 minus 45, which is going to be, let's do a little calculator here just to make sure I'm doing my math right. Sometimes when I'm on the video I get a little nervous. So 45, there we go. We go 45 minus 135. So I have a negative 90. It's pretty sure that's where I was going. And 1 minus 3 is minus 2. Notice, one of the things you might notice so far is when I do the first value minus the second value, I tend to end up with two negative numbers. Not always, but what we've done so far. Those cancel out and become positive, positive. 90 divided by 2 is 45. So my slope here happens to be 45. I could say it's 45 over 1 if you wanted to, not necessary. So we're saying that for in 1 hour, we go 45 miles in 1 hour. That's our slope. In part B, it wants to find the average rate of change between hours 1 and 5. If this truly is a linear function, then my rate of change won't vary. I should still end up with 45 over 1. All right. So let's go ahead and look at this then. We're looking at 1 hour, and we're looking at the 5th hour. I'm going to go ahead this time, just because I see we always get negative, just to show you that it still works. I'm going to do, this is my, we're going to go make this my x2 and this my y2. I'm going to do a y2 minus y1 over x2 minus x1. Again, like I said, it doesn't matter which way you go, as long as you use the same 2 2's and 1 1's, you'll be just fine. All right, so y2 in this case is 225 minus my y1 over here is 45 over x2, which is 5 minus 1. So I have 225 minus 45, which is 180, and 5 minus 1 is 4, and that reduces down again to 45 over 1. And so I can see that those indeed are equivalent, which tells me it certainly is a linear function. Okay, so that's number 8. For number 9, we have another linear function, and it says the f and x values are shown. Again, don't get hung up on f and x. That's just the nice way of saying y. There's not a huge deal, but now it's what's a function is what f and x is. But it works the same. We have our t-chart here with the values of x and the values of y. And I want to do the same thing like I did above to find the average rate of change from one point to the next. So I can look down at B, and B I'm going to do 3 to 5, and here I'm going to find whichever one I want to do. So let's just pretend I'm going to do 3 to 4. So we'll make this my x1 and my x2 for the first time. This is my y1 and my y2. And so I'll plug those in. Let's go ahead and go from 2 to 1. So let's go y2 minus y1 over x2 minus x1, just so we end up maybe with a nicer number. It may not work because I have negatives, but we'll work it out. So if y2 is minus 8, and I'm going to subtract from it a minus 13, that's my y2 minus y1 value. My x2 is 4 minus 3. So this becomes a plus plus. 13 and a negative 8 is a 5, and 4 minus 3 is 1. So my average rate of change is 5 over 1, or I could simply write it as 5. Doesn't matter, it's the same number. When I look then at the next one, well, is it still the same from 3 to 5? I'll do the same thing. Here's 3. Now we're going to go to 5, so let's just make some new colors here. This becomes my x1, and this becomes my x2 at 3 to 5. And this becomes my y1, and this is my y2. So let's plug it in again. y2 minus y1 over x2 minus x1. Okay, y2 was a minus 3 minus the value of y1, which is again a negative 13. And x2 is 5 minus the value of 3. This is a plus plus. 13 minus 3 is 10. 5 minus 3 is 2. And 10 divided by 2 again is 5 over 1, or 5. So there's my slope from the value from 5 to 3. No change, so I know it's still a linear equation. We're still in good shape. Okay. Number 10. For number 10, it asks you to graph this function. F of x equals negative 3/4 x plus 3. Alrighty. So, couple things. Again, this becomes a y. If I want to think of it as a y value, if that helps you out, you can rewrite it as y. Totally up to you for now. Doesn't matter. I have my slope, which is negative 3, 4, which tells me that I'm going to be going down, because it's negative 3, and I'm going to go over 4 each time. That's going to be my pattern, negative 3 over 4. Okay, so one place to start with this, you can make a t-chart, t-table, and see what you come up with. I could also start with my x and y intercepts. I'm going to start with x and y intercepts because I have a fraction. It's a little bit funky with a fraction sometimes. So I'm going to go ahead and put an x, and I'm going to do a y. And I want to say when x is 0, let's figure out what y is. And when y is 0, let's figure out what x is. Because that will give me a point on the y-axis and a point on the x-axis. And because it's a linear function, I can connect the dots with that one. Okay, so let me come over here to the side, and let's work on x equals 0. So y equals negative 3/4 x plus 3. If I set x equal to 0, then y equals negative 3/4 times 0 plus 3. Y equals 3. So when x equals 0, y equals 3. So here's 0, and here's 1, 2, 3. Here's my first point is at 0, 3. Now let's find out what happens when y equals 0. Can I do that? Sure I can. Y equals negative 3/4 x plus 3. We're going to say that y equals 0 plus 3. And I go, oh, I'm at 0. Is that okay? Nope, it's not okay. So let's move things around. Let's subtract 3 from both sides. So I end up with a negative 3 equals negative 3/4 times x. I want to get the x all by itself. So to do that, what I'll do is multiply both sides by the reciprocal. So I have a negative 3/4, so I'm going to multiply both sides by a 4/3, and it's negative because I want to put a positive number here. I'll multiply both by negative 4/3, and that will leave me on this side with just a positive x. So negative 4/3 over here times a minus 3, or negative 3. This will cancel out. Off it goes, leaving me with just the x. And over here, a negative 4/3 times a negative 3. The 3's cancel out. This is like 3 over 1. You multiply it this way. The 3's cancel out. And I'm left with a negative 4 times a negative 1, which is positive 4 equals x. So when y equals 0, x equals 4. So when y equals 0, and here's my point, 4, 1, 2, 3, 4, my value is 4, 0. And it says to go ahead and graph that there. So the way I'm going to graph that is I'm going to take a little card here. We have Bear Stage Presents, Catch Me If You Can. Hope you see it or will see it. And I'm going to play Connect the Dots, just like that. And that becomes my graph for that equation. Alright, that's number 10. Let's take a look at number 11. Number 11. It says find the slope of the line that passes through negative 5, negative 3, and negative 3, 2. I'm actually going to go ahead and push pause real quick because it looks like I'm already at 28 minutes. I want to make sure I don't run over time, and we'll start with part 2 in just a second.